Right, so I will now start. My name is Geoffrey Fox. I'm introducing the summer school on science clouds. And if everybody's ready, we'll get started. You seem to be not quite ready yet. So to begin with, I will note the various web resources there are. There is the site on tumblr.com, which is the Science Cloud Summer School. That has a schedule. And there is on the Future Grid site, there is a project page, which has instructions for registering to use Future Grid, which will be used for some of the laboratory sessions. And also on the Future Grid website, there is a forum where people can post questions. These will be questions for long-term answers, not tactical questions. I believe if you have a tactical question, you contact your local organizer or AI, and they somehow inform me that you have a question or inform the speaker. And we also have the Twitter hashtag here. So an activity like this needs to thank an awful lot of people. And I don't acknowledge everybody here because some of them are implicit in the various speakers. The work at IU is funded largely by NSF and the Lilly Foundation. I'd like to thank the Virtual Summer School in Computational Science and Engineering for hosting this. That's led by Sharon Glotzer and Eric Harper, Scott Lathrop, and Megan Lefebvre have been critical in getting this off the ground. We have this magnificent video infrastructure which is transporting this high definition material across the world. And here Mike Miller, Chris Eller, and Jeff Rogers are to be thanked. All the sites have organizers and AIs. I won't acknowledge them, all the speakers. Mary Nell locally is providing the hospitality. And I would also like to thank the staff of Future Grid who will have worked very hard to set up Future Grid to host this event. And I have not listed many dedicated students I can see in front of me. I apologize to them for not mentioning them. And so this slide here covers the topics of this summer school. We have, covers a pretty broad swath of material and is trying to help both people interested in applications, people interested in sort of the research in this area. And if you look at the enrolled people, there are actually several enrolled people who sort of come from the system administration side. So these are the people who will be either supporting directly clouds or helping users get to work on clouds. So we have, if you look at the schedule, we have several application talks. The talk after this is on biology, and there will be other couple of talks on Friday on the life sciences. Other talks will cover the use of high-performance computing on the clouds and various specific technologies. In order to build a cloud, you need virtual machine management systems, which include Nimbus, Eucalyptus, and OpenStack, which we will which we will be using in the various different sessions. We will have several talks discussing how you combine clouds together, how you move from one to the other, which is called bursting. And also a critical feature of clouds is the concept of virtual networks and virtual clusters. You want to be able to, people are used to real clusters, but in clouds you can have virtual clusters. And we will have several talks on that. The building block of the cloud applications is the image, which has got the operating system and your software in that image, and that's sometimes called an appliance. And we will have talks on that. In terms of the technologies, we will have Many talks will implicitly or explicitly use services and compose them with workflow. Michael Wild from Chicago will be talking about workflow this afternoon. And other talks will discuss one of the, as we'll see, critical uses of clouds, or what I call loosely coupled collections of jobs, sometimes called bags of tasks. Those will be discussed several times. Especially tomorrow, Judy Chu will be hosting the day. We will be discussing parallel computing, which is an exciting use of clouds, and I expect of great interest to several of the people here, because we have here an audience that comes from the high-performance computing community. Also tomorrow we will discuss novel data models, which is clouds have pioneered, sometimes called NoSQL technologies, so-called data parallel file systems, which is HDFS, object stores, queues, and tables. And finally, we will have talks on some of the key technologies which are essential to build clouds, which include security, that's on Friday, networking, and the use of GPUs with clouds, because we want to get the highest performance, and GPUs give the highest performance. So those are the topics. The rest of this talk is devoted to a basic introduction, and you will be filled in with the details in the later talks. So now we go to my talk, which has 7 sections. And the initial sections is a broad overview of data-intensive computing and clouds. I should say that clouds are particularly relevant for data-intensive applications. Clouds, in some sense, came from, a lot of them, you could say, came from e-commerce and information retrieval, Google and Bing and things like that. And those are all data-intensive applications. And if you look at those type of applications, they're particularly suitable to clouds. So if we look at the general trends in computing, we have several important trends. And I've highlighted in red some of the ones that are particularly relevant here. I mentioned the data deluge, the huge increase in the amount of data. Another important issue, which is relevant for clouds, is lightweight clients. We can have lightweight clients like smartphones because they can connect the cloud to do the work that they need to do to make significant, to give you significant knowledge. Another important issue is multi-core. A few years ago, people didn't quite know what to do with multi-core chips. How on earth can you use all these chips all these cores in a chip? But now it's relatively clear of one critical use, namely, if we have clouds, those cores can be hosting individual virtual machines, and they can be independently processing the different usages of the cloud technology. So multi-core chips are extremely important and suitable for clouds. We will discuss a little bit later on how this is connected to the Exascale initiative, which is the main sort of thrust of high-performance computing. We will, of course, discuss clouds and also the fact that there's some relevance to green IT. And another important issue with clouds is the fact there are a lot of jobs in the area of clouds. There is a report, probably biased, sponsored by Microsoft, which says there's some 14 to 15 million jobs connected to clouds by 2015. So here's a slide which is sort of relevant for the life sciences and why we need a lot of computing. It shows you the change in this field. This illustrates really the data deluge. This is a plot of the cost of sequencing versus the cost of computing. We have Moore's law, which is the straight line here, showing how the cost of computing is decreasing with time. And then the blue line is the cost of sequencing, which has obviously gone down about 3 orders of magnitude faster than computing. But this is an illustration of how the data deluge is producing compelling computing needs, because in order to process all this sequence data, we have to use computers, and computers have not gotten cheaper in the same rate as the data has become available.